Okay, I was really, really almost done. So then we get this, then we get that again. Okay, so, no, I don't see, yeah. Oh, what's happening? Just a sec. 1 second. Okay. No.
Now it's fine.
No. Now it's time? Okay.
No. Disappeared. It was okay, but then disappeared again.
It's most unfortunate. I'm so sorry.
No problem. Yeah, like this happens of technology.
Yeah.
It's much it's less safer than nuclear technology. Yeah. Imagine that it would happen with reactors like this. If you click like F5 or whatever to get full
screen. It was
screen.
actually the last slide. Yeah.
So, okay.
No, it was actually the last slide anyway. So, and it
yes. We don't hear you, Adriaan.
Okay. Yeah, I'm not saying anything. I finished my presentation.
Okay, thank you very much.
Can you hear me now?
Yeah, we hear you. Thank you very much. I had a comment on this, that you say that subcritical, the delayed neutrons can be considered as an external neutron source, as in a subcritical reactor. But frankly, I don't agree, because the number of delayed neutrons depends directly on the number of fissions in the reactor. So it's not external independent source, like in ADS, for example. It depends, so it's still connected directly to the number of fissions and number of other neutrons.
Yes.
What do you think?
Yes, that is correct, except in the yeah, that is correct. Of course, that is correct. Otherwise, it wouldn't work. Otherwise, you couldn't shift up the energy. The point is, though, that in the case of an accident or so, for a very short moment, the source is independent of the power, because it is delayed. So it is actually, it refers to some time in the past. So in that sense, it will be a constant source for the next few milliseconds, and that is important.
Yeah, agree.
But it is a bit semantics. I agree with that. But the fact is still that on prompt neutrons, the reactor is always a little bit subcritical, and you need the delayed neutrons to make it exactly critical, and that's what makes it nicely controllable.
Okay, thank you. So now, any questions or comment? Questions to Adriaan?
Yeah, I have one question.
Yes, please.
Precursor equation and prompt neutron equations, both are having a very much time difference, because the prompt neutron have equation have a fraction of second. It's 10 to the power minus 2 or 3 second or 8 second, 10 to the power minus 8 second. While the precursor neutrons, whatever the neutrons coming from precursor, delay neutrons, their generation time is in second.
I can't hear you very well.
Also, the voice is not very clear. If probably if you can type yes, in the chat, this would be great. Any questions from here, from the audience here? You? No. I have question like why you start. You explain is that you like you want to.
I think I understand the question.
Okay.
Can you hear me talk?
Yes, we can hear you.
Yeah.
Can you hear us?
Yeah, now you are able to hear me.
Okay. Okay. I can hear you, yes. Just let me.
Yes. So that equation of precursor neutrons.
I couldn't hear you very well, but I think I know what you want to ask. Can you hear me? Sorry.
Yes, yes, yes,
Sorry.
yes.
Yeah, so what you're saying is that the prompt neutrons have a very short life, or they appear immediately after the fission in the order of 10 to the minus 8 seconds, and the delayed neutrons appear of the order of seconds. And you're saying that if you look at these equations, you now try to solve a time-dependent equation that has a time scale of 10 to the minus 8 and 10 to the and then a few seconds. But actually, that's not what you're doing. You just assume that the prompt neutrons, they are all prompt. So the only thing you have to worry about is the time differences between the different delayed neutron sources. And those time differences are not so big. I mean, there's not 10 orders of magnitude difference there. So even if you're with your Fortran, you can handle that. Was that your question?
Yeah, that is true, sir. But when we are solving that, yeah, it's true. But when we are solving that both the equations together, that equations comes as like a steps equations. That interval we cannot take a very small as a like a delay neutrons or prompt neutrons interval, because for solving that equation we need the interval time is very short. Then the computational time will go very high.
Yeah, but how small do you want to make it? You want to make it,
Yes, sir.
well,
But,
you can take 1 microsecond. Microsecond is 10 to the minus 6. For the delayed neutrons, that is almost, that's okay. And if you want to get to 1 calculations per second, so that is not a problem. If you want to go back to 10 to the minus 8, then it becomes a problem. But you don't care about that. You only care. I'm sorry, I don't hear you.
Yeah, but for solving that, now I'll come same thing for that delayed neutron. So in that delayed neutron, that interval is very
sorry,
big.
I don't hear anything.
Okay, sorry, this is, maybe you can type in the chat, and then I believe Adriaan could answer also in the chat.
Are we still in the meeting?
Okay, sir, I will write in chat, sir. Okay, thank you.
Please type in the chat. So, any questions here? No? If not, I just have a question. I understand you are, how to say, I don't say as advertising, but you like these molten salt reactors, but you decided in the campus to build gas-cooled reactors. So, it is much easier. Why? Adriaan? Okay, looks like Adriaan is disconnected again. We will like to thank him for his lecture. And now let's have a coffee break, and we come back.